Welcome to another MBF video. In this video we're going to be explaining how to construct economical and very practical #1 cover slip glass bottom tissue culture chambers using 25mm diameter plates. So for this instructional video, and the equipment that you'll need in order to make these plates are a cutter, a Dremel tool. In this case it's a handheld Dremel device using this tip, which is a 117 Dremel high-speed cutter tip, carbide steel cutting tip. You're going to need any low-cost polystyrene plastic tissue culture dishes at 25mm with a cap. We prefer to use the simple ones that don't have any shoulder onto them. You're going to need a 10 ml conical tube for marking, a Sharpie, low cost as possible, #1 cover glasses, and 22 by 22 millimeters. And the adhesive, in this case we're going to be using Norland Optical Adhesive 68T. This is a special adhesive formulated for UV curing of cover glasses or glass to this type of acrylic plastic. Okay, so for safety, because we're using a high-speed cutter device, this is going to be operating at maximum RPM. We're going to have to use safety protection for the eyes in the forms of goggles, hearing protection for the ears in the forms of safety earmuffs, and protection for the hands in the form of a rubberized glove to hold the dish. So the first step is going to be to take the bottom out of one of these dishes, and don't be too concerned about sterility at this point. And what we're going to do is mark the appropriate sized hole that we're going to cut into the bottom of the dish. And the way to do that is by simply placing the conical tube onto the dish and tracing the diameter, or use any other template that will give you approximately this diameter. What you want is that diameter to be less than 22 millimeters. And then we're going to go ahead and cut the hole out of the bottom of the dish. And this is going to be using this high-speed cutter. So this part is going to be pretty noisy, but so it will require the use of the hearing protection and of course the eye protection. Okay, so after the hole has been cut out, I'll make a few points here. First of all, this is going to take a little bit of practice in order to get up to skill. And you're going to be very careful. Drilling the hole, you can freehand it, or you can actually use a marked template. It doesn't really matter. After a while you'll find you'll probably get used to using it by freehand. Once the hole has been cut, you want to be very careful to remove any of the plastic burrs. Also, you noticed as I cut, I traced in the opposite direction of what the cutting wheel was spinning, and that was so we didn't end up with the plastic burrs appearing on the outer circumference of the hole, but on the inner circumference. So all the plastic burring appeared in the segment that dropped out of the middle. All right, so once the holes have been cut, and you can do this for as many plates as you want. Typically, a person will sit down and do a dozen or 2 dozen at a time. The next step is to actually glue on the adhesive, glue on the cover slip. So we're going to be using this Norland optical adhesive. which is a UV curable adhesive, which means that as a glue, it actually will never dry in air, but it does respond to ultraviolet light. An additional tool that could be useful for this type of assembly is pressurized air of some sort, either from a can or from a air compressor. And what I'm going to do is lay on approximately a 2 millimeter thick coating of the adhesive, around the entire circumference of the hole. And you want enough adhesive, a considerable amount on there, so you get a good seal on the cover slip, but not used to excess. That's a bit excessive, but for this demonstration it'll do. I'm going to recap the glue, and we're going to place on a #1 cover slip over the hole. And apply just the right amount of pressure to make sure we have a nice effective seal around the entire circumference of that hole, and you should be able to visually see this. And then you can go ahead and repeat this for as many dishes as you want before we go to the next step. Another alternative method for even lower cost, basic everyday use for glass bottom cover chambers is to use a silicone adhesive. And this is air dried. So a good example of this is a simple kitchen and bath type of GE Silicone 1, something that is labeled as 100% silicone rubber, clear, so there's no color in it whatsoever. These typically cost under $5 at any hardware store. What I've got here is a 35 millimeter dish where we've cut out our 18 millimeter hole, as I've shown you previously, an 18 gauge needle, and in this case we have 25 millimeter glass circular #1 cover slips. What I'm going to do is just take out this 18 gauge needle and use the applicator that comes with the product and just poke a small hole. And what that's going to do is give us a nice controlled amount of silicone to come out. And you simply squeeze it as you would a tube of toothpaste, and just give it a good amount, enough to get a nice seal all around the edge of the hole. You'll notice this has an odor of very strong acetic acid odor, so you might want to use it in a more ventilated area, although I don't believe it's toxic. And we're going to simply place on the cover slip, and this material is thicker than the optical adhesive, so it's going to need a little bit of pressure, and you should be able to apply just enough pressure so that you can see that it's completely sealed around the circumference of the hole. And you're basically going to leave it, and it's going to take anywhere between 30 and 45 minutes to completely cure. If you're going to do a large number of these, do it all overnight and let it cure overnight, and the next day you've got glass bottom incubation chambers that are extremely durable. This silicone adhesive is watertight, it's non-toxic, it's optically clear, and it's extremely strong. You get a very strong bond between the glass and the plastic. It's also, because of the nature of the rubber, it's which is a misnomer, it's actually a polymer. It's very flexible, which means that you can put these slides on ice and go up to 37 degrees or 42 degrees pretty quickly without worrying about too much thermal effects cracking the glass cover slip. So if you're going to do the types of experiments where you're going to be working at extreme temperatures, either on ice or on heat shock, these may be preferable to the Norland optical adhesives, UV curable glues in the rest of the demo. The stage after this is the stage that's in common between both methods, either using UV curable adhesives or using the air curable silicone adhesive. In this case from General Electric, but any one of them will do. So now we're going to go to the next step in this procedure to make these glass bottom cover slip dishes. So here's the dish that I cut at the bottom with in the hole using the Dremel lithium stylus device, and the glue's been applied, and I have nice coverage between the glass and the plastic, but this glue will never dry by air. It requires cross-linking by a pretty intense ultraviolet radiation. And so for this, I'm using the ELC500 UV chamber, which is specifically designed for this application. And what you can see in there is there's a rotating turntable and 2 high-intensity ultraviolet lamps. We're producing about 30 milliwatts per centimeter squared, and this is on a timer with a maximum time of 9.9 minutes, or approximately 10 minutes. So what I'm going to do is put in the dish bottom and the dish top, and you can pile these up, so you can put these around in a circle, put as many as probably about a dozen in there quite effectively, set it for 9.9 minutes, close the lid, and press start. Alright, so this step in the procedure is going to do 2 things on the manufacture of these dishes. The first thing it's going to do is cross-link that glue and offer a very effective and extremely strong bond between the glass cover slip and the bottom of the polystyrene dish. Now, unlike other glues that, for example, silicones that you can use that will just air dry, the advantage of these glues is that the cover slip will sit extremely flat on the bottom of the chamber, and this will give you optimal results when you're actually on the microscope. The other thing the ultraviolet treatment will do is sterilize the dishes. So you only going to need about 10 minutes to cross-link the glue, but what we do is we then put it in the chamber for an additional 10 minutes, and then once those dishes come out of the chamber, they're completely sterile and they can be stored dry. And once they've been stored, prior to use, it's a good idea to just take them out again, and just before the experiment where you're going to seed out your cells, put them back into the UV chamber and blast them with UV light again for approximately another 10 minutes. And this is to ensure that you won't get any kind of contamination and that you're working with sterile plates constantly. And this is exactly how this procedure is done by the industry, where you can buy these pre-made dishes, but the cost per dish of buying them pre-made can be as high as $2 or $3 per dish. By this methodology, we're looking at approximately 50 cents per dish. The cost of the optical adhesive is minimal. There's going to one-time investment of these UV chambers, which I think are actually just very useful devices to have around a lab where you're doing tissue culture for the sterilization or manufacture of custom devices. The other advantage of this system is the hole that you drill into the bottom of the dish can be any shape you desire. It can be multiple holes. So for example, in this demonstration, I've drilled one large 20 millimeter hole, but I can certainly drill that as a square or carve 4 small holes to make 4 microchambers in which we can do drug treatment experiments. So at the end of the 10 minutes, we're going to actually incubate it again for another 10 minutes, and then once those dishes come out, they're completely sterile and they're ready for use immediately.